Quantum phenomena are often treated with almost religious awe. Entanglement, uncertainty principle are handled like they were divine revelations. From the perspective of Burkhard Heims' six-dimensional world, however, we will see that they appear as something almost trivial, definitely not something fundamental to our understanding of reality. Hello and welcome to Six Dimensions in Color. My name is Schmid, and on this channel I explain to you Burkhard Heims' worldview in understandable language and with clear examples. It's been almost 3 months since I finally moved to Dubai. And here's now my personal center and my basis for the NATHAL training, which I offer worldwide. NATHAL allows you to delve into these dimensions I'm talking about on this channel theoretically in the living experience inside your mind. If you're interested in that, go to my website nathaltraining.ae or visit my Instagram channel. Perhaps you have heard that regarding quantum theory, there is the so-called Kopenhagen Interpretation. All statements on quantum theory have a probabilistic character. For example, a particle is present at a certain location and at a certain momentum only with a certain probability. Its future behavior is, allegedly, completely acausal. This is what we've been able to reproduce with great success in the laboratory for more than 100 years now. The Kopenhagen interpretation of these phenomena was mainly shaped by Max Born, Werner von Braun, Paul Dirac, and John von Neumann. It states that this uncertainty is a fundamental principle of nature. Fundamental means you cannot provide a deeper course for it and take it as God-given if you want. As you may know, Burkhard Heim and Werner Heisenberg were far from being friends, and they were also far away in their interpretation of quantum phenomena. Albert Einstein is credited with the saying, "God doesn't play dice." Einstein believed that quantum theory is simply incomplete, and we simply do not know what's behind that and causing this seemingly acausal behavior. And Heim very much agreed with Einstein, and he even solved it. Solved the riddle that Einstein has been puzzled about for all of his life. I want to play a piece of tape which was recorded when Heim made a statement about how he views quantum theory. It's in German, of course, but I put in the English subtitles.
Nun ist natürlich die Frage, die Quantentheorie, gerade in ihrer statistischen Ausdeutung nach Jordan, ist ja ein wunderbares Instrument. Aber sieht diese Quantentheorie mit ihren Wahrscheinlichkeitsangaben die Sachverhalte nicht eigentlich bloß von außen? Die sieht es doch nur von außen.
Bloß soweit die Messung trifft. Ne? Man könnte eigentlich sagen, damit ist die Sache wieder aufgeflogen. Das ganze Unschärfeprinzip eigentlich, nicht? Mit dem
Ja, das Unschärfeprinzip, das wird nicht aufgehoben.
Nein, aber
es wird nur in eine andere, höhere Ebene verlagert.
Ja, eben, man könnte sagen,
vielleicht fundamentaler als das, was Heisenberg hier für kanonisch konjugierte Größen fand. Denn die Überlegung dieser Unschärferelation für die Bürgerschaft, das ist doch ein ganz billiger, einfacher Gedanke.
Und deswegen ist man ja umso erschlagener, nicht? Dass die das nun also als gleich das Seiende und das wirklich vorhanden. Also
sagen wir mal, ich habe die Unschärferelation immer nur gewertet als ein sehr praktisches Hilfsmittel.
Ja.
Aber fundamental ist ja noch nicht.
So Burkhard Heim says here nothing else than quantum theory is like a good engineering approach for everyday application. But there's nothing mystical or fundamental about it. The other person you hear speaking, by the way, is Hildebrand von Ludwiger, his Heim's long-term friend and student for over 40 years, whom I knew personally for the past 6 years of his life. Now Heim has found this mechanism underlying that what causes this observable behavior. Or more cautiously put, he developed a method that dissolves the contradictions between two camps. The one camp being quantum theory and the other general relativity. Both are considered powerful theories and very much in line with empirical observations. And yet it seems impossible to reconcile them mathematically or even philosophically. The state of an elementary particle in Heim's view, let's take an electron for example, can be viewed as a metroplex structure. In this structure, we can identify the gradual tectonics, which goes from 0 through 3. Then there is the syntrometric tectonics, which describes the probabilities, the possibilities for the electron's current state, its position and momentum. And remember the third type of tectonics and the principle of telecentrism, which I introduced in the last video. I'm coming to that in a moment. The observable facts still apply and are not under dispute. You cannot pinpoint the exact position or momentum of a particle at the same time. However, Burkhard Heim now argues as follows. The state of the particle, every single moment, is described in the syntrometric tectonics of its metroplex structure. It goes for every tiniest moment of its existence. There are unimaginably many syndromes, though not infinitely many. There are nowhere in Heim's theories you will encounter infinities. A particle's history can be determined. Heim called this the morphological historicity, and this is unambiguous, meaning that the past proceeds into the future into one definite direction. The future, however, is selected from one of many, many possible states which qualify the next moment. This selection is also unambiguous because there is a law behind it. The morphological historicity results from the telecentric nature of the electron, not of the physical particle, but of the idea of the existence of the electron, which is telecentered in both the beginning and the end of the universe. You can state that because the particle is governed by laws and symmetries which fulfill the requirements of telecentrism. And that not only holds true for the electron, but for all other mass particles, all particles which underlie the laws of quantum physics. Yet when measured, this appears as something statistical and apparently are causal, because this law that governs the behavior is simply delivering the appearance of statistical behavior. The difference is subtle. We observe something apparently statistical, but the law behind that, what causes the statistical appearance in the foreground, that's deterministic. It is deterministic because it is telecentric. It's just one possibility which is chosen, unambiguously chosen, from a many great varieties. But since we cannot perceive X6 and the selection law lying there, it must appear as in four-dimensional space as a statistical process. And this comes down to a redefinition of causality itself. Causality, under the circumstances of quantum physics, appears as acausality, but only appears as such. Let's illustrate this with the commonly known quantum phenomena. Let's start with entanglement. Einstein called it the spooky action at a distance. In such cases, two particles, the entangled particles, share a common selection law, which is superordinate in the transcendent realm of its existence. From four-dimensional space, viewed from four-dimensional space, it looks like these particles are somehow intertwined and with apparently no means of communicating with each other, but just go into the higher perspective and then it's quite obvious. The distance between them doesn't matter in transcendent space because it's not a spatial temporal thing. So the governing, entangling selection law, it applies to both particles and they can be indefinitely apart. In 6 dimensions, distance doesn't play any role. If you embrace the existence of 6 dimensions, entanglement seems almost trivial, definitely nothing mystical or something you have to lose sleep about. The same goes for quantum coherence, like we observe in laser light or in the biophoton field. You have a superordinate governing law which is acting on every single quantum particle we have. and it creates a behavior that is coordinated. And then let's talk about all the experiments that the peer group and others did. The anomalous Princeton Engineering Research Program I'm talking about, PEAR. They conducted extensive experiments about paranormal phenomena between 1979 and 2007. That included mental influencing quantum processes like radioactive decay or white diode noise. Mental concentration can beyond any doubt influence quantum phenomena and shift the probabilities of the results. And it shows that the process, of course, is still statistical, but probabilities are shifted in one direction or the other, compared to if it would be left alone. Think about these mental syntroclines I was talking about previously. If a connection is formed between the mind, which is a highly organized system, and quantum and single quantum particles, which are several intellectual levels below the organizational level of the mind, then an organizing field can act upon the particles and you get the results that are observed. Such experiments have been conducted by many other groups all over the world as well, and they prove beyond any doubt that the so-called randomness is only random if completely left alone. Randomness is now merely a specific state of organization. A very low one, but it's still a state of organization. All these examples show that there is a directed process which causes the actualization in the background of the syntrometric tectonics in X6. So what are the consequences for quantum philosophy? It necessarily follows that the Kopenhagen interpretation of Heisenberg and Bohr et al. Is wrong. And Einstein was right, and so was Heim. The observable quantum phenomena are merely a consequence of a process in the background that we cannot directly see, but we can nonetheless know. Thus, quantum theory is in no way fundamental. And what does that mean metaphysically now? Primarily, it means that there is meaning behind it all, and that life and the universe are not just organized at random. Personally, I always saw this alleged randomness of quantum theory as something very negative, as quite a negative worldview, because it berefts reality of all purpose and higher intent. I shall also not conceal from you that I have little patience with arguing spiritual truths with the help of quantum physics, because what is done here is nothing else than taking a foreground observation of particles, of single particles, which are a very unorganized state of existence, and ontologize the heuristic laws which have been found to describe them, and transpose that to all of reality. You can't give any logical reason to do that. It is proposed that the laws that describe matter in its most unorganized state are so fundamental that they can be directly applied to mental phenomena. Mental phenomena are the highest state of organizations human beings can usually experience. And never does anyone care to give a deeper logic why this is allowed to be done. In a nutshell, you can argue so many things with quantum theory and yet explain absolutely nothing. Quantum theory is not fundamental to reality, but in reality, reading books about quantum philosophy is probably a fundamental waste of time. In closing, I want to introduce a term which Burkhard Heim used a lot and which we will talk about in the coming videos, the term of a maxim. As defined by the German philosopher Immanuel Kant, a maxim is the personal will of any given subject. The law of affect, the one that determines the historicity of our particles, we will henceforth call a maxim, therefore. Let your maxim always be to expand your knowledge, and if you follow it truly, The only logical consequence of it will be that you tune in again for the next video in 6 dimensions and in color.